Hi guys, and welcome to Activity 4 in the Year 8 Physical Sciences course. In this activity we're going to be looking at kinetic energy. Okay, so let's define what kinetic energy is. Basically, kinetic energy is the energy which is involved in movement. As an object goes from A to B, there's going to be some movement around, and that is going to involve energy because work will be done. Now, what will determine how much energy it's got is basically how fast it's going. The faster it moves from A to B, the more kinetic energy you've got. And likewise, the slower it's going, the less kinetic energy it's got. Now, there are two main variables that will determine the amount of kinetic energy. That is the mass and the velocity or the speed. And these can be put together in a mathematical equation as shown below. Kinetic energy equals 1/2 times the mass times the velocity squared, or the velocity multiplied by itself. Now, there are a number of things that we need to understand before we start using the equations, and that is the units that all of the variables need to be in. Now, kinetic energy, being energy, is always in the units of joules, so you put a capital J after the value that you've got for your energy. Your mass must always be in kilograms. Now, if it's in grams, then all you have to do is divide it by 1,000, and that will turn it back into kilograms. The velocity or the speed must always be in meters per second. Now, I will show you later on how you can convert from kilometers per hour into meters per second, but this is not part of the assessment for this year. But it will extend those students who are finding the work easy. For now, just make sure that you check that it's in meters per second. Okay. So how do we use the equation? Well, here's a step-by-step process which may help you work your way through using the equation if your maths isn't great. So the first thing you've got to do is look at the question. In the question, you need to find the mass and say to yourself, is the mass got units in kilograms? If the answer is yes, you're done. If not, then you must convert into kilograms first. As I said, if it's in grams, divide by 1,000, and that will give it to you in kilograms. Then do exactly the same for the velocity. Is it in meters per second? In most cases in this unit it will be, but if it's not, then you need to convert into meters per second. Once you've done that, then I suggest the next thing that you do is you square your speed. You multiply the speed by itself. Once you've done that, you'll then get an answer, and to that answer, what you then want to do is to multiply by 1/2 and then multiply by the mass and hit the equal sign. That will then give you the kinetic energy, and all you then have to do is to place a capital J next to it, and that will give it to you in joules. Okay, well, it's easy to put this step-by-step process down, but let's see it in real life running through a worked example. Okay, so we've got this example where a car travels at 14 meters per second and has a mass of 550 kilograms. So let's write down what we already know. We know the velocity is 14 meters per second. So the units are correct. The mass, 550 kilograms, so the units are correct for that. So we don't have to do any conversion. And we want to find the kinetic energy. Okay, so we know the kinetic energy, we can write down the formula. This will be given to you on your exam paper. So it's 1/2 mv squared. So the first thing we do is we square the velocity. So that's 14 squared, you can put that in your calculator and hit equals, or 14 times 14, which comes to 196. So once I've got my squared value for V, I then need to substitute that into my formula. So I do 1/2 times my mass, which is 550, times my velocity squared, which was 196. Put that into your calculator, hit the equal sign, and you should end up with 53,900 joules. Now, this could be converted into 53.9 kilojoules by dividing by 1,000. And this was the practice that we did in the previous example. Okay, so fairly straightforward. Now it's your turn. Have a go at these two examples. What I suggest you do is you pause the video and have a go at the examples doing exactly what I showed you earlier. Okay, I'll see you in a minute. Okay, welcome back. All right, so how did we go? Well, let's look at the first example. We've got a girl traveling at 5 meters per second and has a mass of 45 kilograms. So let's write down what we know. The speed is 5 meters per second. The units are correct. The mass is 45 kilograms. correct units here, and we are finding the kinetic energy. So I don't have to do any conversions. I know I'm finding the kinetic energy, so I need to write down my kinetic energy equation, which is a half mv squared. Then let's put in the numbers, substitute the numbers in for the letters. Well, the mass is 45 and the velocity is 5. So what I then have to do on my calculator is a half times 45 times 5 squared, hit the equal sign, and I end up with 562.5 joules. How did you go? You get it correct? Well done. Alright, let's have a look at example 2. See if you get this right. We've got a surfer travels at 3 meters per second and has a mass of 102 kilograms. So again, let's write down what we know. His speed is 3 meters per second, units correct, so no conversion. The mass is 102 kilograms, again, units correct, no conversion, and we're finding the kinetic energy. So because we're finding the kinetic energy, I would need to find my formula for kinetic energy and write it down. That's a half mv squared. Substitute in for the m and the v, and we end up putting into our calculator a half times 102 times 3 squared, hitting the equals, and we get 459 joules. Did you get that one right? Great, so that's 2 out of 2. If you didn't, then go back, try it again, make sure you know where you made your mistake. If you don't, watch the video and then obviously that will help you through. Otherwise, ask your teacher and I'm sure they'll be only too pleased to help. Okay, let's have a look at another 2 examples. Pause the video and go through them, but be careful with example 4 because a conversion has to occur, and I'll run through that if you have problems. So pause it now. Okay, how was example 4? Did you manage to get through it? Alright, well let's start off with example 3. We've got a skateboarder travels at 2 meters per second with a mass of 57 kilograms. So let's write down what we already know. The velocity is 2 meters per second. The mass is 57 kilograms, and the kinetic energy has got to be found. So the kinetic energy, it can be found by a half times the mass times the velocity squared. So let's substitute in for those variables. So I get a half times 57 times 2 squared, hit the equals on your calculator, 114 joules. Should be getting fairly easy now. Hope you got it right. Okay, here's the sticky one. Here's the one which is going to require some conversions. We've got an aircraft which travels at 500 kilometers per hour. The speed is not in meters per second, so I must convert from kilometers per hour to meters per second, and I'll show you how in a second. But its mass is in kilograms. It's 275,000 kilograms, and we've got to find the kinetic energy. So we write down what we know. We know our velocity, 500 kilometers per hour. We know our mass, 275,000 kilograms, and we're looking for the kinetic energy. So the first thing we must do is convert the velocity or the speed into meters per second. Well, kilometers is easy to convert because there is 1,000 meters in a kilometer. So if I multiply the speed by 1,000, that will change the meters section. I then have to divide the speed by an hour, the number of seconds in an hour, because I don't want to know how long it goes in an hour, I want to know how far it goes in a second. So there are 3,600 seconds in an hour. That's 60 seconds and 60 minutes. So 60 seconds in a minute and 60 minutes in an hour. So 60 times 60 makes 3,600. So I multiply the speed, 500, by 1,000, then divide by 3,600, gives me 139 meters per second. Now this is the way that you would actually convert kilometers per hour into meters per second all the time. The only number that would change is that 500, because that is the speed. So you just have to change, put in whatever the speed is, multiply by 1,000 and divide by 3,600, and that will convert straight away to meters per second. I hope that makes sense, but remember, don't worry if you don't get this at this stage. This is an extension question and will not be in the assessment. Okay, so now I've converted into meters per second. I've got my kilograms in mass. All I need to do is calculate my kinetic energy. So put down the formula, half times m times velocity squared, and then substitute in for those letters. So it's a half times 275,000 times 139 squared. And that comes out as 2,656,637,500 joules, or if I convert it into kilojoules, it's 2,656,637 kilojoules. That's a massive amount of energy in an aircraft, but it makes sense why the number is so big, because the aircraft is going very, very fast and is very, very heavy. Okay, so I hope you managed to get through those. If you look further down on this course, you will see that there's a worksheet where you will be given a mass and the velocity and asked to calculate a variety of different kinetic energies, and you'll also be able to be asked to have practice of converting from joules to kilojoules. So I hope you find that useful. Join me again in the next activity, but for now, thank you for watching.